Alright, so I'm going to start talking about kinetics here. And essentially, kinetics is looking at the speed of reactions. So whenever we're looking at a reaction, the way that we would find the rate is based upon how fast either reactants disappear or products appear. And we do that in molarity over time, so change in molarity over time. So if we're looking at this equation right here, we have hydrogen and iodine reacting. If you wanted to write the reaction rate expression, well, you would do something like this right here. There's a negative in front of hydrogen because hydrogen is a reactant. So these things over here disappear while we form this. And so anytime when you're looking at change in molarity, if it's a reactant, you'll put a negative. If it's a product, you'll keep it positive. And then obviously that's over time, the change in time. Any rate is some change over time. So like I just said, a positive rate means that you're increasing that concentration. A negative rate means you're decreasing. So reactants typically decrease, and products are going to increase. So this is for a generic reaction. It all is the rate of a reaction is based upon the coefficients, the molar quantities here. And so when we write it out, each of these is set equal to one another. So if you know the rate of disappearance of A, you can actually find the appearance of D. Now, remember, this is generic. Some reactions will only have one reactant, or only one product, or more, whatever. But this is what you would do. You do 1 over the coefficient times the change in molarity of that substance over time. If it's a reactant, it has the negative. If it's a product, there is none. So here is a practice problem. If you wanted to find the average rate of the reaction in this time interval, it's 10 seconds. Iodide, right here, it's a reactant, so you do negative 1 over 3, because there's a 3 here, and then you're going to multiply by the change in concentration, which is final minus initial, so the final is 0.868 minus 1, okay, over the change in time, which is 10 seconds. Oops, that was a bad 0. 10 seconds. So this whole thing right here will give you the reaction rate. And I'll let you do the other ones on your own. So how do we measure reaction rates? We use spectroscopy, like I have mentioned before, and like in our lab earlier in the year. We can measure how fast a reaction occurs by, sometimes, first of all, we have colored substances, but other times we have to put an indicator in there, and as the reaction proceeds, a reactant or product will either gain color or lose color, and we can reference that with a clear cuvette, and by doing that we can actually keep track of the reaction, because remember, the absorbance and the concentration are related to one another. And so if you know the change in absorbance, you can get the change in concentration. Alright, that's a good place to stop.